All right, so here we have the individual round of competition 3, the district competition in 2012, 2013. Now I am getting 2 alternative answers on this one. So if you have how they got the answer on the answer key, I'd love to hear it. Don't keep it a secret. All right, what single discount is equivalent to 2 successive discounts of 11% and 8%? So the way to think about it is if you have an item that is $100 and you have an 11% discount, that item would now cost $89. And if you then take another 88%, sorry, if you take another 8% off, that means that you're going to be spending 92% of it. And then, so all you really need to do is multiply 89 times 0.92, and you'll know that the item now costs $81.88, which means the amount that you've saved on this item is going to be 100 minus this amount, which is going to be $18.12. So it seems to me that your overall discount is going to be a discount of 18.12%. Now, the answer book has 18.82%. I think that is a typo. Again, if you can figure out why, I'd love to hear it. So for our next one, the next one's a little trickier. I sort of view this as a guess and check problem, and I'll tell you why. If we want product of 4 consecutive positive integers is 1 less than 305 squared, so find the smallest of the 4 integers. So if you were to write an equation, first integer would be x, the next one would be x plus 1, next one would be x plus 2, x plus 3. And if you were to multiply those together, this would be a bloody mess. It would be gigantic, and it's not going to be the most helpful thing in the world. So here's what I would suggest. The first thing is to say 305 squared is 93,025. So let's start with something easy. If I have 10 times 10, if I have 10 squared and I square 100, then I'm going to get 100,000. Now it doesn't seem like a whole lot, or it doesn't seem terribly close to 93,000, but in the scheme of things, we know that it's going to be somewhere around 10. So I would start to do my guess and check around 15. I'd say 15, 16, 17, and 18. Let's see what we get. So we're going to go 15 times 16 times 17 times 18. 73,444 is actually fairly close in the scheme of things to 93,000. So I would just go up 1 and say 16 times 17 times 18 times 19. And there we have it. So my smallest number is simply 16. And you see how moving every number up 1 ends up having a huge change in the product. Number 3. Number 3 again. All right. Fraternal triplets are born. What is the probability that they'll be the same gender? Well, there are 2 ways to do it. The sort of blunt and obvious way is to make a counting tree. That's a boy. First twin is going to be boy or girl. Second is going to be a boy or a girl. Boy or girl. The third one out so I have a total of 8 possible outcomes. 2 of them are all one gender, which is 1/4, and they want it in a percentage. The other way you can think about it is, you have 2 genders, you have 3 kids, so you have a total of 8 possible outcomes, and you only have boys and girls, so there you have it. This next one, I'm a little shocked it's on here. It's really kind of painfully obvious. We know this is 3 and we know this is 3, right? So the distance from here to here is half of 3. The distance from here to here is half of 3. Well, half of 3 plus half of 3 is 3. We know it's a square, so 3 times 3 is 9. Pretty simple. Moving on to number 5. Now, number 5 is one that I am getting a different answer, and if you can tell me where I'm going wrong, I'd love to hear it. We have a digital clock, and we want a sum of 6 on a digital clock. Now, I know 12 midnight, 12 is bigger than 6. I can't get any hour that's bigger than 6. I really can't do a whole lot. So I'm assuming, but maybe not. Maybe it's all the digits together. We'll see. This is the way I'm thinking about it. So if I have 105, that's 1. 150. 114. 141. 123. 132. So there's 6 options, right? So then the next set would be at 2. At 2, we could have 204, 240, 213, 231, 222. Then for 3 o'clock, we'd have 303 and 330, and there's not much else I can do about that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 15. Here's 16. Here's 17. And then here's 18. So in a 12-hour period, I'm getting 18. But I guess it could be in how it's wording it. So if we're counting 12 as a 1, 2, then we could also have 0, 3, right? I mean, is this possible? Is this an issue of interpretation? I'm not sure. So then I could also do 12, so that's 3 already, right? Is there another way to do it? I mean, I can't think of a third way to do it. No, not really. So then 11, would 11 be 11 plus 2? Again, I'm not thinking this is going to work out right. And then 10. So that's going back to our 1, so we have another 6 ways of doing it. So maybe that's it. So we'll have another 6 ways of doing it. When we had 11, that's 2, right? So this would be, let's see, the 1s would only happen once. So then we'd have 6 ways of doing this when it was 11, right? Or 5 ways. And then 12 would be this repeated. What I'm thinking is that she was thinking a 24-hour period and doubled it. I don't know. You tell me what you think. Again, I'm still getting 18. So the following is a box plot of the number of national parks for each state and territory. It includes 27 plus 2, so this is 29. Now you'll remember that in a box plot, the distance from the box to the whisker is 25% of the data. The distance inside the box to the median is 25% of the data. And normally the box looks like something like this, where each part is a quarter of the data. So what is a quarter of 29. Well, a quarter is 7.25. You can't have 2.25 of a state or a territory, so it's just 7. So that's what I get. You like the song? Me too.